All right, so today we're going to learn about the period of a sine or cosine graph. So yesterday you learned about amplitude, which was the maximum and the distance from the midline to the max or to the min. Period is, if I take a look at my sine graph here, let's start off with that one. So if we start here at 0, what happens is we go up, we hit a maximum, we go back down to the midline, we go down, we hit a minimum, and then we go back to that midline. And then after that is going to repeat. So notice you go from 0 to 2 pi, we complete what we call one wave of your sine graph. All right, same thing happens here with cosine. Your cosine starts at the max, then it goes to your midline, then it goes to your min, it goes back to your midline, and it goes back to your max. That is one wave of a cosine graph. And when you complete one wave of your graph, that's known as the period. So the period is how long it takes to complete one wave of the graph. So for a sine graph, that means to go from your midline to your max, to your midline to your min, back to your midline again, right? That's one wave. You've gone through a max and you've gone through a min. For your cosine, that means you're starting at your max, going to your midline, going to your minimum, going back to your midline, and going back to your maximum again, right? For your original sine and cosine graphs, you start at 0. Where it ends up for both of those is at 2 pi. So the period for a graph, original sine and cosine graph, no changes as far as horizontal stretches and shrinks, is going to be 2 pi. So now let's see what happens when we start changing some things around on here. So let's take a look here at this one. So this tells me that it's a sine graph. So again, with a sine graph, you want to start on your midline. You're going to go up to a maximum. You're going to go back to your midline. You're going to go down to your minimum. And you're going to go back to your midline. That is one wave of your sine graph. So we started at 0, and where we ended up here was at pi over 2. So for this one here, the period is equal to pi over 2. Now, there's other places you could pick. We want to try to pick the easiest one here. So, and the way you want to think about it too, it's pi over 2 minus, it's the ending x value minus that starting x value. So like, for instance, if, and it's a little hard on this one because we would need kind of more of our graph to really see. But if I just chose to start somewhere else, I would subtract the ending x value minus the starting x value, and that can tell me the period. All right, let's take a look at this one. This is my cosine graph. So in my cosine graph, you start at your maximum. So we're starting at that maximum here at 0. So you're going from 0, midline, minimum, back to midline, back to maximum. So again, starting on this one was at 0. Ending x value was at 4 pi. So I went from 0 to 4 pi. If I subtract those, the period on this one, or the amount of time or length it takes me for one wave of that graph, is 4 pi. So you have a period of 4 pi. Now, with your amplitude from yesterday, it was really easy to see where the amplitude came from in terms of your graph. But if I go back to this, back here, sine of x and cosine of x, they both have a period of 2 pi. Right? Where does that 2 pi come from in relationship here to your sine and your cosine graph? Because there's no 2 pi in the equation. Like the amplitude, it all had to do with the number that was in front of your sine and cosine. So where does that 2 pi come from in terms of your graph? So what it has to do with is now if you're multiplying your variable times a number of, if you have sine of some number, b times x, or cosine of b times x. And the way you find the period is by taking 2 pi and dividing it by that value of b. So that's why in the original sine graph where you had just sine of x, since b was 1, 2 pi divided by 1, that's why we had a period of 2 pi. Same thing with the original cosine graph. If b was 1, cosine of x, 2 pi divided by 1. That's why in just a plain old cosine of x graph, you have a period of 2 pi. So we're going to find the period for these functions right here. So we have sine of 3/4 x. So in this case here, b is equal to 3/4. So we don't include the variable in there at all. So the period is going to be 2 pi divided by 3/4. Now, the one thing, don't leave it like that, please. All right, you are in honors pre-calc. You should be able to simplify that. So when you do simplify it, you turn it into multiply by your reciprocal, which is 4/3, and then multiply straight across. That gives you 8 pi over 3. There's your period. That's how long it's going to take you to repeat one wave of your graph. It's going to take you 8 pi over 3 versus what you originally had, which was 2 pi. On the second one here, b is 6. You're multiplying the variable by 6. So my period on this one is going to be 2 pi over 6. Well, that simplifies into pi over 3. So now instead of this graph taking from 0 to 2 pi, it's going to take from 0 to just pi over 3 to repeat. So it repeats, so it's a much shorter distance. This all goes back to horizontal stretches and shrinks back from the very beginning of the year. And because you're doing something to the variable, not to the function, it's always the opposite of what you think. So in this case here, since you're multiplying by 6, it's actually a horizontal shrink. That this graph, again, the original graph goes from, if this is 0, and we'll make that 2 pi, the original cosine graph, that's the cosine graph. So the original cosine graph does this, with this being my 2 pi right here. But this one is going to repeat one wave from 0 to pi over 3. So 0 to pi over 3 is somewhere in here. So this is going to make a much shorter, it's going to shrink it down a lot. It's going to be a horizontal shrink in that case. So, right. We'll get more into that. Don't worry. Right now, I just really want you to practice identifying that period. All right. That's what you're going to be looking at. And tomorrow, which we will be back on Zoom finally, we're going to put both of those together. And we'll be working with your amplitude and your period then. All right. So have a wonderful day, everybody. And I will see you on Zoom tomorrow.